This is the Unit 5, Geometry B Unit 5 portfolio video. It's to help you complete Lesson 8 in Unit 5, the car wheel portfolio. And I'm just reading some of the instructions here. You will turn in the results, measure the circumference of 3 different vehicles, 3 different tires of 3 different vehicles. Vehicles can include cars, bikes, scooters, tractors, etc. Determine the number of full rotations the tires of each of the vehicles will complete in 10,000 miles. Choose one of the vehicles to keep track of how far you'll travel in that vehicle for a week. Calculate the average number of daily rotations made by the tires and use your data to predict when you will need to switch the front and back tires. All right, so there we have it. I'm going to simplify this just a little bit here. It's easier to measure the diameter, the distance from end to end of a tire, than it is to measure the circumference, and from the diameter we can calculate the circumference. Okay, so I'm going to make a table or take a Mabel, and we're going to have the diameters. Okay, so in one case I'm going to make it a skateboard wheel, and we're going to say the diameter is let's make it 3 inches. Okay, another one is going to be a scooter, and it's going to have a diameter of 9 inches. And another one's going to be a bicycle, and it's going to have a diameter of 23 inches. So we've got a wide variety of diameters. Okay, let's calculate the circumference for each of these. Okay, I'm going to use Desmos, so let me pull up Desmos. Desmos.com/calculator. Okay, so here we go. So we're going to say the diameter, the circumference is pi times the diameter. So pi times 3, 9.42 inches circumference. Okay, pi times 9, 28.27 inches, 28.27 inches. And times 23, 72.26, 72.26 inches circumference. Okay. All right, so determine the number of full rotations the tires of each of the vehicles will complete in 10,000 miles. Okay, so just to highlight what I did, this is a skateboard. This is a scooter, and this is a bike. Okay. All right. How many rotations will each tire undergo in 10,000 miles is the question. Okay. So we need to know how many feet there are in a mile, how many inches there are in a mile. Okay. So we're going a distance. Here's the way this calculation works. And we need to show our steps here. So write this down. 10,000 miles over 1. And we're going to change miles to feet. Now there are 5,280, 5280, 5 tomatoes, 5,280 feet in 1 mile. So if we do it this way, the miles cancel out. And there are 12 inches in a foot. 12 inches in 1 foot. And the feet cancel and leave just inches. So there are 10,000 times 55280 times 12 inches in 10,000 miles. So let's do that. 10,000 times 5280 times 12, 633,600, 633,600, actually 633,600,000. inches. Okay, that's how many inches there are in 10,000 miles. So every time a tire turns or rotates, one time it goes the circumference of the tire. So if the tire has a circumference of 9 inches, every time it rotates, it goes 9 inches. Okay, if it has a circumference of 72 inches, every time it rotates, it goes 72 inches. So we're going to take the total distance in inches and divide by the circumference, and that'll give me the rotations in 10,000 miles. Rotations. So we're going to divide. We're going to take 633,600,000 divide by each of these. Okay, so 633,600,000 divided by, and I'm going to simplify it, I'm going to just say 3 pi, so I get a more accurate answer. 67,227, 67, comma, 227, comma, 48. So 67,227,048 rotations. Okay. The scooter, on the other hand, we're going to divide not by 3 pi, but by 9 pi. 22409. And 16. Okay. Now just a note here, you don't use my diameters. They're mine. Do your own calculations. Use different diameters, please. Okay. And rotations, and then 23. So we're going to do 23. All right, so 8,768. 8,768, comma 745. So 8 million, so about 67 million rotations for the 3-inch diameter, 22 million rotations for the 9-inch diameter, and 8 million rotations for the 23-inch diameter, or 9 million. Notice it's going down, so the bigger the tire, the fewer the rotations. That kind of makes sense. Think of a race between a man with long legs and a man with short legs, right? If both men run the same distance, the long-legged man is going to take fewer strides, fewer steps. The short-legged man is going to take more strides, more steps. By the way, the world's fastest man, Usain Bolt, is very tall. I believe he's about 6'8". So he's got a stride length that's quite long. In fact, what that does, that gives him an advantage in that he's able to continue accelerating longer. He's continuing to accelerate when people he competes against have reached their maximum stride already, their maximum speed. So that's how he's able to win. Long legs, more distance for every stride, fewer strides in the same race. Okay. So determine the number of full rotations of the tires of each vehicle in 10,000 miles. We did that. Choose one of the vehicles and keep track of how far you travel in that vehicle for a week. Calculate the average daily number of rotations made by the tires. Okay, so here we go. Let's pick the bike. Okay. And we have 4 days a week here, or 7 days a week. We have Sunday and Monday, Tuesday and Wednesday, Thursday and Friday, and Saturday. Let's say Sunday I went 15 miles. Monday I went 8 miles. Tuesday 12 miles. Wednesday 3 miles. Thursday 6 miles. Friday 17 miles, and Saturday I didn't ride my bike. Okay, so these are numbers I made up. I'm not going to take the time to keep a log or a journal or anything like that, and I don't expect you to either. Just make reasonable numbers. Okay. So choose one of the vehicles, keep track of how far you travel in that vehicle for a week, calculate the average number of daily rotations, average number of daily rotation. So we need to figure out the average. Okay. So 15 and 8 is 23, 35, 38, 41, 58. 58 is the total, divided by 7. 7 times 8 is 56. So that leaves 2. So 8 and 2/7, right? So 8 and 2/7 miles per day. So to figure out how many rotations that is, we need to figure out the inches per mile, right? So 8 and 2/7 miles, where you need to convert those miles. 5,280 feet is 1 mile, and 12 inches is 1 foot. So feet cancel, miles cancel. We are left with inches. So let's bring up Desmos and do that calculation. So 8 and 2/7, that's the easiest way to do a mixed number in Desmos, times 5,280 times 12. Okay, and we get 524, 524,983 inches. Okay, and now I'm going to take that and divide by the circumference of the bike tire, which is 72.26. So I'm just going to do this. I'm going to put a parentheses around the whole thing. And actually, I'm just going to say select all and divide. And I'm going to divide by 23 pi. Or I could divide by 72.26. And I get 7,266. 7,266 rotations per day. Okay. Now, it asks us to use your data to predict when you'll need to switch the front and back tires. To know that, I need to know how many rotations to switch the front and back tires. I suppose a reasonable number is once I go 100,000 rotations. So how many days, let's say how many days to reach 100,000 rotations? To figure that out, I'm going to take this number, I'm going to take 100,000 and divide by 7,266. And it's about 14 days. So by that figure, I should be changing my tires, switching them every 14 days if I was going for 100,000 rotations. All right. So again, I want you to do this, just what I did here, writing down the tables that I did, showing the calculations that I did. But you need to do them for your own measurements. So don't use 3 inches, 9 inches, and 23 inches. Use your own. Okay, you can make them up just so they're reasonable, but you need to do your own calculations and get your own results. Okay. Then there's also a little bit of a writing assignment. You need to explain what happens when the tire size increases 20%, when the tire size decreases 20%. The answer lies in the fact that it's an inverse relationship. So when the tire size increases 20%, your number of rotations in 10,000 miles will decrease 20%. When your tire size decreases 20%, the number of rotations in 10,000 miles will increase by 20%. And that's because the short-legged man takes more steps in the same race as the long-legged man, if that makes sense. Hope that helps.